tendency. I have also explained you the measures of dispersion and the measures of distribution. This is what we have seen under the head of descriptive statistics. Further, I had discussed about the chi-square test, that is a non-parametric test that I have discussed. Using Excel, we have seen also that how we can apply the descriptive statistics using Excel, and also we have seen how we can perform chi-square test. Both the forms we have seen yesterday, that is the goodness of it we have seen, and also we have seen the independence of attributes. So this is what I have discussed yesterday. Today onwards, I am good. Means today agenda is I'm going to cover today the t-test. In t-test, I'll discuss all the 3 forms of the t-test. So as per the tradition, I'm going to share my screen. In that, I'll show you firstly the presentation part, and then I'll share the Excel with all of you to talk on the applying of the t-test using Excel. So I want to get confirmation from your side whether my screen is visible or not.
Yes, ma'am, visible.
Okay. Thank you so much, sir. I think many of you are either writing on the chat, or either you are using these different emojis to give me some confirmation or other thing. But I want to clear you this thing when we are using the Google Meet. So when I'll present my screen, I am unable to see anything in the meeting except my screen. So if you want to interact with me, please try to unmute yourself and then you can ask me. Otherwise, I think it is quite difficult for me to check the chats, and also I cannot see your emojis expressions. So this is my humble request. If you have the genuine query which you want to ask me during the session, in that case, you can unmute yourself, right? Okay. So now I'm starting with the t-test. So firstly, I want to tell this thing that yesterday I discussed the chi-square test, and I said this thing that chi-square is the non-parametric test, means the test which is not bothering about the population distribution, means whether the sample which we have drawn from the population, that is normally distributed or not. So that way we are not bothering about the population distribution. And also in a case that when we are having the categorical data, in that case we can apply the chi-square test or the non-parametric test. Other than then, I have told you this thing also, when the assumptions of parametric tests are not meeting, in that case also we can go for the non-parametric test. So today, as I said, I'm going to talk about the first parametric test, that is the t-test. So the t-test is the part of the second category of the statistics, that is the inferential statistics. I think you people can recall yesterday I said that we can divide the statistics into the 2 categories, that is descriptive statistics and the inferential statistics. So I have explained that descriptive statistics helps us to summarize our data, means whatever data we are having, we want to understand that which type of data we are having, what are the variables we are having, what is their averages, or what are the averages of that particular variables which are contained in the data set. Also, we want to understand the spread in the data, and also we want to check the distribution of the data. So that all we can do using the descriptive statistics. Further, after checking about the data set, further we are going to use the same data for the testing of the hypothesis. So testing of the hypothesis comes under the inferential statistics. So inferential statistics is a discipline, or I can say is a one part of the statistics which allow us to check something for the population using the sample. So same when I talk about the t-test, so using the t-test also, we can take a sample from the population, and on the basis of that sample, whatever we will conclude for the sample, we are trying to generalize that thing for the population also. So that is why we can call this type of things as a inferential statistics. Now, the second thing is, generally t-test we are using to test certain hypotheses. So generally whenever we are talking about t-test, so the purpose of t-test is to find the significant mean difference. So whenever we are interested to find significant mean difference, in such cases we are applying the t-test. As I just said, that t-test is a category or is a test comes under the parametric test family. So this is a part of this category. And generally when we talk about t-test, we can use the parameters, because if I want to define parametric test, so the other definition of parametric test is test which considers, or the test which consider the parameters of population. So what parameters? Parameters like the mean and standard deviation, or the proportion also comes under the parameters, right? So when we are considering the parameters of the population, now parameter can be the characteristics or the features of population. So features or the characteristics of population we can get using the mean and the standard deviation or the proportion. So using these things, we can understand the parameters. And when we are using these parameters in any particular test, this way that test becomes the parametric test. As I said, when we talk about the t-test, so we are using the t-test to compare the means. We want to check whether there is a significant mean difference in the population mean or in the sample mean or in the two groups mean. If such type of things we want to do, in that case, we are opting for the t-test. Now, to get the table value of t-test, as yesterday, I think you can recall this thing when I was discussing about the decision rules. I said this thing that if we want to make a decision to accept or reject the hypothesis, in that case, we need to have, if I want to say that if I want to decide upon using the manual calculation, so in that case, we need to have the tabulated value, and we also need to have the critical value. That is the, sorry, we table value and critical value, one in the same thing, and we also need to have the calculated value. So using those two values, those two figures, that is the table value and the calculated value, we can compare these two figures and we can make a decision whether we are going with the alternate null hypothesis or not. So now to get the table value or the critical value for t-test, we need to have two things. First is the degrees of freedom and second is the level of significance. So using these two figures, we can get the table value. But as I said, we are using the Excel, as we are, means all of you are here for understanding all these types of tests using the Excel. So in that case, we do not need to be bothered about these things. Usually using the Excel, when we will apply t-test, Excel itself gives us all these things. We do not need to calculate these things. But for manual calculations, we need to know this thing conceptually, that to get the table value, we need to have the degrees of freedom and also we need to have the level of significance. Am I clear on this slide? Any doubt so far?
No, ma'am. Thank you.
Yeah, thank you, ma'am. Yeah, thank you for the confirmation. Moving ahead, now I'll talk about the types of t-tests. So we can bifurcate t-test into the two categories. First one is the one sample t-test and second one is the two samples t-test. One sample t-test, that means when we want to compare population mean and sample mean, that is a case of the one sample. Two samples t-test can be further bifurcated into the two categories, that is the independent samples t-test and the paired samples t-test. So that way this is known as the two samples t-test. Now we will see one by one all these three things together, what is the meaning of one sample and the independent and the paired samples t-test. So now, if I talk about one sample t-test, so this point is very important for all of you. So I want to drag your attention on this point. If you are involved somewhere else, please look at the screen and try to understand what I'm saying to you people. Because once you are understanding that when we can apply t-test, you need to have the knowledge of these points. Because whenever you are having the research data, in that case, generally we feel ourselves helpless that which test we need to apply on the data. So that way, using your objectives, you can decide upon your hypothesis, and using your hypothesis, you can decide upon your test. So for hypothesis purposes, what type of variables you need to have? Firstly, I'm explaining you that. So in case of one sample t-test, we need to have only one variable. If you're making your notes, because all things are not written on the slide, so if you are making your notes, you can write this thing. For the one sample t-test, we need to have only one variable. Generally, that variable is treated as a dependent variable. Fine. Now, on what scale it should be measured? So for measuring or for the measurement scale point of view, we can say this thing, that variable should be continuous. That is a numeric or the quantitative variables we need to have for performing one sample t-test. So this is the major requirement for the one sample t-test. Further, The purpose of one sample t-test is we want to compare sample mean with the population mean. Means we want to see whether whatever sample we have drawn that is representing our population or not. So in that case, we want to compare sample mean and population mean. So this is the important part to understand one sample t-test. So in that case, again, I'll repeat, if you are having one variable on continuous scale and you want to see whether your sample is a good representative of the population or not, or whether the sample is drawn from the same population, if you are intended to find this thing, in that case, you can apply one sample t-test. So I hope, am I clear on the first part of this t-test? Any doubt so far?
No, ma'am.
Okay, thank you, sir. Coming to the next point, that is now I'm talking about the now I'm talking about the two samples t-test. In this category, I'll take the first test, that is the independent samples t-test. So for independent samples t-test, we need to have the two variables. You can see here I have written we need to have two variables. First variable should be continuous variable. Second variable should be the categorical variable. And in the categorical variable, we need to have the two labels. Continuous variable will be treated as a dependent variable, and categorical variable can be treated as an independent variable. So DV means dependent and IV means independent variable. So this is the main requirement for the independent samples t-test. Again, I repeat, for independent samples t-test, you need to have one dependent variable on continuous scale and one independent variable on categorical scale with the two labels or two categories. Say, for example, if I want to compare suppose weight of male and female, right? So in that case, weight is the variable which is on the continuous scale, which is the numeric variable, and the gender with the two labels, that is male category and female category. So we can say we are having two variables, weight and gender. And I want to compare the weight of male and female, whether is there any significant difference in the mean weight of male and female or not. Clear to all? In that case, you can apply independent samples t-test. Is it clear?
Yes, ma'am.
Okay. Now moving ahead.
Excuse me.
Yes.
So one sample t-test we can use in the pilot studies also for
No,
parameter.
I didn't say this.
No. I'm trying to get. I'm trying to get understand. You said one sample t-test. We can compare whether my sample is a representative of my universe.
Yes. No. I said this thing, but it is not in that sense, whatever the sense you have taken, ma'am.
Okay.
I said this thing, the purpose of one sample t-test is to tell you whether your sample is a good representative of the population or not, right? This is what I
Yes.
said. And
Yes.
you have interpreted it like that, but maybe somewhere there is a problem of understanding. So
Okay.
it is not like that one sample test we can use for the pilot study. Means when we are having a small sample and then we want to check whether the sample is a representative of the population or not. No. When we talk about the pilot study, it is a little different thing. Pilot study generally we are doing for checking our scale. Scale
Yes.
meaning is our questionnaire. Say for
Yes.
example, I have developed a scale for motivation, right? I want to check the motivation level of my students to whom I am teaching. I want to check what is their motivation level. So I need to understand this thing, that motivation is a qualitative phenomena, right? I cannot directly measure it. There is no measurement or there is no gauge is available, a yardstick is available which can help me out to measure that thing. So for that, I have developed a questionnaire. All the questionnaire will be intended to, which are somewhere or indirectly, they are telling me something about the level of the motivation of the people. Got it? So that way, all the questions which are there on that particular scale, they would be intended or they would be intended towards to help us for measuring the motivation level of the students. So in that case, generally what we do, we want to check the reliability of the scale. So for the
pilot study,
purpose,
yes.
we are going for the pilot study.
Yes.
The purpose of reliability, we want to see this thing, whether the scale is reliable, whether it is giving us the same results. Means agar, it means if you are performing that scale on a 30 people. And now when you are actually conducting your research for the research study purpose, say for example PhD purpose, so your sample size would be little bigger.
Yes.
Obviously it would be a bigger enough. We
Yes.
cannot do on 30 people or 50 people. So in that case, same scale you will use for the other sample or the sample with the big size. So in
Yes.
that case, scale should be reliable or consistent. It should produce the same result every time.
Okay.
So that is what we are doing in the pilot study.
Yes.
Here the purpose of the one sample t-test, it only tells you that the sample which you have taken from the population, it is representing the population or not. There is nothing to do with the sample size in that case.
Okay.
And there
Okay.
is no purpose behind the pilot study.
Okay. 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 ठीक है. Thank you, ma'am.
So coming to the next point, now I'll discuss the second part of the two samples t-test, that is the paired samples t-test. So in case of paired samples t-test, we have only one variable. Usually we have one variable, and that variable should be the continuous variable, that is a numeric variable, which we will treat as a dependent variable. So in the case of dependent samples t-test, we will collect the data 2 times for the same variable. Say for example, there is a suppose diet program run by any particular organization. So they are offering that program. Suppose 10 people want to attend or want to take that particular diet program. So what they'll do, what company will do, they will take the weight of those 10 people. They will offer that diet program to those 10 people. And after some days, whatever is the limit, maybe for example, that particular diet plan is giving the effective results after 30 days or 45 days, something like that. So after that period, again the company or the organization will measure the weights of those 10 people. So that way you can see weight is a common variable. We are taking the measurement for the weight 2 times at the 2 different periods. One before taking that particular diet program, and second after taking that diet program. Got it? So that way variable would be same, but at 2 different time periods you will collect the data, and the sample would remain same. Sample means for that same 10 people I will collect the data 2 times. Say for example, if I talk about this FDP, so suppose 100 participants have shown their interest to join this FDP. So what we have done, we suppose we have taken your, we want to see your understanding level for the statistics using the Excel. So suppose we have conducted a quiz and we have collected your scores. And then after 5 days, when I have got to all of you, again we are conducting the second quiz. Maybe the quiz questions are same. And again I am conducting the quiz and I am collecting your responses then. And maybe I'll check whether your understanding level has increased after attending this FDP or not. So that way, understanding is the same, 2 times I am measuring, and again sample is same, but 2 times I am collecting the data for the same sample. That way, this is the case of paired samples t-test. Generally, before, after, pre and post type of things are coming under the paired samples t-test. So this way, these are the 3 various categories of the t-test. I hope it is all clear to all of you.
This is experimental then, ma'am, but like,
yes, we can say this thing that generally when we are using the experimental research design, right? So generally in case of medical field, generally we can opt for the paired sample t-test. Even in academics also we can apply this thing. Similarly, suppose we want to check the for example, performance of the employees. Suppose we have given some training program to the employees. So before taking that training program, what is their performance, and after taking their that particular training program, what is their performance? So that means we want to say this thing that whatever experiment we are doing on the particular sample, whether this is effective or whether it is making any impact on that particular person or not. So that way we can call for paired sample t-test. Generally, the research design should be the experimental. Is it fine, ma'am?
yes, ma'am.
Okay. So I think, shall I move?
Ma'am, I am having a doubt.
Yes.
Ma'am, like suppose if it is a interventional study and we are having 2 groups, suppose we are giving any kind of medicines to one group and another kind of medicine to the another group, and the outcome measure is suppose we are giving it for swelling reduction in any particular kind of condition. So we have measured the swelling prior to the treatment and then after the 20 days of treatment program in first group, and again the same thing in the second group, like prior to the treatment swelling measurement and followed by 20 days of program, again the swelling measurement is being done in the second group. But in both the groups, the treatment is different. Like in one group, one drug is given, and in the another group, another type of drug. So in such cases, we'll be using the independent sample t-test or the paired sample t-test.
So, ma'am, question is here, what is your purpose? What you want to measure here?
Like how the treatment has, what is the impact of the treatment on the swelling? Like
Means you want to check the effectiveness of the medicine or something?
particular medicine, yeah. I
So
want
in
to
that
check the.
case, yeah. So in that case, may I? You want
Yes,
to say
yes, ma'am.
something else?
No, yes.
Okay. So, ma'am, in that case, we want to check the effectiveness of the medicine, right? So,
Right.
as we are only concerned about a particular medicine, so in that case, 2 times we can apply the paired sample t-test. Firstly for the first drug and secondly for the second drug. This is
Okay.
what I think, what I can understand from your point. Because if you want to test whether the medicine is effective or not, so in that case, you can apply 2 times the because sample is also different. For one group of people, you are giving one medicine, and for other group of people, you are giving other medicine, right?
But one characteristic of sample will be same. Like they will be having the same type of swelling, they will be having the same type of condition. So we won't be going for the independent sample t-test in this condition because there is a dependent variable and also the independent variable.
So that is what I am saying, ma'am. Purpose is very important. Say, for example, suppose because if before and after condition is there, in that case, paired sample t-test is applicable here, and 2 times you need to apply that, right? Now we are understanding this thing in some other way. For example, suppose you have written just a minute. I'll take you through the Excel. I think that way it is quite easier for me to explain you all this. So give me a second. I'm opening the Excel sheet, the demo sheet which I have shared with all of you. Yeah. See, right? This is the type of medicine. Got it, ma'am? Suppose I have written this here. So suppose I have written A. Suppose how many I have entered A? 6. Similarly, suppose 6 I have written here also. Is it clear?
Yeah.
Right. Now next, what I want to make here? I want to make here what? The suppose the level of swelling after using it, right? Maybe we are measuring this thing in the continuous scale. I don't know how we are measuring the swelling.
Yes, yeah.
Suppose
It
you are,
will be numerical value.
yeah, you should have that numerical value. So suppose I am writing here 2.1, right? Suppose 1.6, then 3.9, or suppose 2.0, then 1.7 or 8, and then 1.5, 2.9, then 1.3, 1.4, 1.1, 2.8. Likewise, I have written these figures, right? If this is the case, in that case, it is quite clear you can go for the independent sample t-test. Is it clear?
Right.
Now, if you are asking about this thing, say for example, I am using medicine A, right? Now I have a level of swelling before using, right? And then I have the level of swelling after using. Got it? In that case, we will go for the paired samples t-test. Is it clear?
Yeah.
Before and after we need to check. That's why we are using
Yeah.
paired
So that
samples.
is why I am asking you. You need to see what type of data you are having, in which format that data is having, because it is a very statistics. In statistics, you need to decide upon all these things, ma'am. So suppose you are having such kind of data, in that case you can go for paired sample t-test. But if you are taking your data in this format, fashion, in this manner, in that case, you can go for independent sample t-test. Is it clear to you?
Okay.
Then in what case independent sample should be taken? Means in this case, so obviously we understand the paired sample we are taking. Again, if you could just a little bit
I'm not getting,
independent.
sir. Will you please repeat it? Your voice is not much clear to me.
Ma'am, I just want to know in what case then independent sample, independent one we have to take.
Sir,
Paired
I
one
think
we
I
understand.
just explained you. Whenever you want to find the significant mean difference in the two group, you can find here there are two groups, group A and group B. Means the people who are taking the medicine type A, the people who are taking the medicine of type B. Now you want to check whether there is any significant difference, mean difference in the level of swelling, those who are using medicine A and medicine B. So in that case, independent sample status you can apply.
Okay, sure.
Fine. Okay. So I hope, am I clear to all of you?
Yes, ma'am.
Shall I go ahead?
Sure, ma'am.
Yeah.
Yes.
Yeah. Thank you, everyone. So now I am moving to the next slide. Now we will talk about the hypothesis in case of one sample t-test. No, I'll talk about that. Firstly, the tails. Maybe you all have heard about the bell shapes already. I think I have discussed also yesterday when I have shown you the skewness graph and when I've shown you the kurtosis through the shapes. I have shown you. So when we talk about the hypothesis can be the one tail or hypothesis can be the two tail. So now what is one tail and two tail we will see here. So when you are making your hypothesis in this form, in this fashion, here you can see H naught or H0. It is indicating the null hypothesis. So when I have written mu minus X bar is equals to 0. Alternatively, I have written mu minus mu X bar is not equal to 0. So this is a case of two-tailed test. Alternatively means other way of making the two-tailed hypothesis is that when I'm clearly saying mu is the population mean, X bar is the sample mean. When I'm clearly saying population mean is equal to sample mean, or I'm saying population mean is not equal to sample mean. So one in the same thing, here you have transposed this particular X bar to this side, so that way it becomes this. So no, there is no other difference. The way is only ways of the representation is means the differences of the representation only. Meaning is same. Is it clear? So that way you can see when we are talking in terms of not equal to, alternative hypothesis is not equal to. That means I am not sure. It can be the less than or it can be the greater than also. Means I can say mu can be the less than also, mu can be the greater than also, but I'm not sure. I'm only saying that mu is not equal to X bar. So this is a case of two-tailed test. But when you are clearly mentioning this thing, that mu is less than or mu is greater than. So this is a case of one-tailed test. When you are saying that mu is less than X bar, this is your right tail test. When you are saying that mu is greater than the X bar, this is the left tail test. So this way, this is the way of representing your hypothesis using the symbols. Now, if you want to write your hypothesis in terms of text, so you can write for the two-tailed test, you can write this particular section. You can see the first section. You can see the null hypothesis H naught would be there is no significant difference in the sample mean and the population mean. Alternatively, we are saying there is a significant difference in the sample mean and the population mean. Then, if I talk about the one-tailed hypothesis, I can write population mean is significantly more than or equal to sample mean, or I can say population mean is significantly less than or equal to sample mean. Alternatively, you can see population mean is significantly less than, or you can see population mean is significantly more than sample mean. So that way, these are the ways of writing your null and alternative hypothesis in case of one sample t-test for the two-tailed test and for the one-tailed test. Am I clear on this?
Yes, ma'am. Yes,
Yeah.
ma'am.
Yeah, thank you
Yes,
so
ma'am.
much. Yeah, thank you so much, sir. Now, this is the case of independent sample t-test. So I think rather than taking independent sample t-test now, I'll first move to the Excel. I'll explain you how we can perform the one sample t-test using Excel, and then we will come back to the slides again, and we will see that how we can perform, or how, or what are the concepts of independent samples teachers. So I think I am on Excel sheet. Anyone can confirm me whether it is visible or not.
Yes, ma'am.
Yes.
Yes,
Thank
ma'am.
you. Yeah, thank you everyone. Now you can see here we are having the data of height. Height is given us in the inches form. So the height of you can see it is given for the 12 people. So the count is 12. So for 12 persons height is given to us. Say for example, this height I have taken from my class. The students of my class, I have taken this height. I want to compare, suppose as I belong to the Prestige Institute, suppose in Prestige, the average height of the student, suppose I am writing here, the value of mu, suppose it is 66. Now I want to see whether there is any significant difference in the sample mean and the population mean or not. So meaning is this: when we are talking about the one sample t-test, we need to have the population mean. Sample mean, I think we can easily calculate, but we need to compare this sample mean with the population mean. So always you need to have population mean to compare your sample mean. This is the case of the one sample t-test. So you need to assume something. So here I have taken, suppose this is the data of the Prestige students, and I want to see that approximate on an average on an average height in the Prestige is around 66 inches of these students, right? So you can see here, these are the different 12 students heights are given here. Now we want to see using the Excel that how we can perform t-test. So before telling you this, you can see here I have taken the formula also. If you want to perform the t-test, because the drawback of this particular Excel is that when you will see, you will go here in the data view, you can find in the data analysis, you can see, you can go down and check. We are having the t-test paired two samples for mean. We are having t-test two samples assuming equal variances, t-test two sample assuming unequal variances. But there is no case of one sample t-test. So in that case, how you can perform that, I'll tell you.
मिनिटांनी
Sorry.
नाही 20 मिनिटांनी
I
I'm
hope
so
no one
sorry.
is asking anything.
I'm so sorry. It's by mistake, but I want to ask that mu, how you have taken the mu? Is it assumed or have you calculated it?
No, ma'am, obviously, as I said, I think you need to listen carefully. Again,
Yeah,
I'm
I missed
repeating
that
this.
one. I'm
You
really
need to listen carefully. No issues. You again, I'm repeating this. This is the sample mean. Suppose I have taken from my institute only, my college. This is the height of the my college students, right? So I said in Prestige, the average height is 66 inches of these students, right? So this is the population. Means I have taken the sample from the Prestige, and I am assuming my universe is my universe is Prestige only. So in Prestige, generally the average height of the students is 66 inches. Is it clear? So that way, this is the mu I have decided using the particular universe. Is it clear?
okay, ma'am. Yes.
So you need to get clarity on this particular point. That whatever is your population, you need to have the idea about that particular population mean if you want to apply the one sample t-test. Okay, fine.
So it's a kind of standard to that particular population.
Standard means
Matlab, whatever the practice you are assuming, na, ki for that population, this is a tendency.
as I said, this
Yes.
is the data of Prestige students, and on an average height in Prestige or the students of Prestige is around 66 inches.
Yes, yes.
Got it? So that way, as I said, because this is the very important part of the one sample t-test. When you want to apply the one sample t-test, you need to have the idea about your population, because you want to compare your sample mean with the population mean. So you need to know what is your population, what is your universe. You need to know this thing, and accordingly, you need to have the idea about that particular population mean. Got it? If not, in that case, you can assume also. Clear,
Yes,
ma'am?
yes, yes, yes. Thank you.
Yes. Yeah. So now I'm coming and firstly I'm increasing its size. Yes, I increased. Now I hope it is visible to everyone, right? Can I start writing here? May I?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. Thank you, everyone. So here you can see this is the formula I have written, right? So firstly, I am calculating here the sample mean. So how I can calculate sample mean? Anyone? How I can get the sample mean?
Divide by number, no? Single digits.
Yes. Or I can use the average function also, the range. And that way I can calculate the average of my sample. Is it clear to everyone?
Yes, ma'am. Yes.
Yes. Now mu already we have taken. So I am writing the mu is 66. Now coming to, please mute yourself. So now I'm coming to this denominator part. This denominator part is known as the standard error of mean. So I'm writing here standard error of mean. Formula would be standard deviation divided by square root of n minus 1. This is the formula which you need to use. I hope I'm audible to all of you. I don't know. One person is there in a meeting, forgot to mute himself or herself. Am I clearly audible? May I proceed?
Yes, ma'am.
Okay. So now I think these two things are clear to everyone, which I have written here. May I proceed from here?
Yes, ma'am.
Yes.
Yes,
I was talking about the denominator part of this formula to get the t value. So here we are having x bar that we have calculated. We are having mu. We have assumed this. This is written here. I'm talking about the denominator. This is the standard error of mean. So to get this figure, we need to use the formula standard deviation divided by square root of n minus 1. So firstly, I'm calculating here standard deviation. So I'm writing here S. Here it is coming as STDEV that I'm using. And then I am giving the range of my variable and pressing enter. This way I'm getting standard deviation. Is it clear to all?
Yes, ma'am.
Yeah. Now coming to the
Can you repeat it again, ma'am?
okay, from where, ma'am?
Standard.
Okay. Equal sign type
Yes.
STD. We can find here STDEV.
Okay.
Then I'm giving the range of the data.
Okay.
Closing the bracket, pressing enter. Now coming to this, n is total count
12.
you can find 12. We have
12.
seen, I think previously it is 12. I need to calculate n minus 1. So n minus 1 would be
11.
equal this minus 1. This is 11 mean. So coming here, writing the equal sign using this standard deviation divided by writing SQRT, that is square root, and then passing 11, closing the bracket, pressing enter. This is the standard error of mean. I hope it is clear to all. Formula I have already written. You can see from here and apply the formula to get a standard error of mean. I hope everyone has found this. May I proceed to find the value of t, that is t calculated we are getting here. So you can put here the equal sign. After putting the equal sign, you can see here it is giving us x bar minus mu. So I'm using the bracket. X bar means this minus mu is this, closing the bracket, divided by using the standard error of mean. Is it fine? Clear to all?
Yes, ma'am.
Three fields I have taken. Can I press enter? Is it fine?
Yes, ma'am.
Okay.
Yes, ma'am.
So once you will press enter, you would be able to see the value of your calculated t. It is 4.712. I hope it is visible and clearly you can find this thing. Can I proceed?
Yes, ma'am. Yes, ma'am.
Now we need to have the the p value. So for p value, I think I have already given you the formula in the sheet. You can find. You need to use t dot dist dot rt, right? Here you need to provide the value of calculated value of t, which we have already calculated, comma, the degrees of the tails. So we are using suppose 2 tails. Done?
What is this 2, ma'am?
Whether you are going for one tail test or two tail test, that you need to write. Fine.
Fine.
Press enter and you will get the p-value. Okay. So now this is the p-value. Suppose we have written the hypothesis. There is no significant mean difference in the sample height and population height, right? Suppose this is our hypothesis and we want to test this hypothesis at 5% level of significance. So that means the LOS would be 0.05. Now we can compare the P. So you can see here P is greater than or less than?
Less than, so we'll reject it.
Yes, so P is less than 0.05 and we can conclude here that we are not going with the null hypothesis, and we can conclude this thing that there is a significant mean difference in the sample height and the population height. Is it clear?
Yes, ma'am.
Okay. So I hope it is clear. May I move ahead? You can find 2 exercises I have given you to practice one sample t-test. I am coming back to the slides. I hope there is no other doubt. May I move ahead?
Yes, ma'am.
Okay. So now I will talk about the independent sample t-test. As in the previous slides, I told you this thing that for the independent sample t-test, we need to have 2 variables. One should be the dependent, other should be the independent. If I talk about the dependent variable should be numeric, that is continuous, and independent variable should be categorical. And it should have at least 2 categories. No, not at least, it should have only 2 categories. That is the case of independent sample t-test. Talking about its hypothesis, so you can see the null hypothesis, we can write it like there is no significant mean difference in the dependent variable corresponding to the categories of independent variable. Alternatively, we can say there is a significant mean difference in the dependent variable corresponding to the categories of independent variable. So this is the case of two-tailed test. When we are saying there is a difference, but whether the difference is greater than or less than, that we are not explaining clearly. So this is a case of two-tailed test. Alternatively, we are writing there is no significant difference in the mean salary. Suppose, means this is the example I have taken, and I'm saying you say for example, I want to compare the salary of male and female students. Suppose students have got the placement from the college, and we want to compare whether the male students have drawn more salary in comparison to the female, or maybe they both are equal, or there is any significant difference. We want to compare that. So that way we can write there is no significant difference in the mean salary of male and the female students. Alternatively, we can write there is a significant difference in the mean salary of male and female students. So this way, this is an example for the independent sample t-test. Now, if I talk about the case of symbols, so in case of symbols also we can write our hypothesis. So you can find when we are saying we are comparing the 2 groups, the male group and the female group. So this is the salary for the male group, this is the salary for the female group. So these are the 2 means of the 2 groups, right? So if we are saying there is no difference, means both the means have no difference, and we are giving as 0, it is giving us 0. Alternatively, we are saying that there is a difference which is not equal to 0. Or you can write this thing, I think wrongly I have written this thing here. You can write this as x1 bar is equal to x2 bar. In a hurry, I need to make the changes. It should be x1 bar is equal to x2 bar. Similarly, x1 bar is not equal to x2 bar. So this is a case of two-tailed test. For the one-tailed test, when you are clearly stating this thing in the alternative hypothesis, whether the difference is in one group is less than or greater than to the other group. In that way, this is a case of one-tailed test. Is it clear to all? Any doubt so far?
Clear, ma'am.
Okay, thank you so much, ma'am. So again, now I'm switching to the Excel first, and then we will talk about the paired samples details. So again, I'm coming to the same Excel sheet, and you can toggle in between these worksheets, and you can find the fourth sheet with the name Demo Independent. You need to click on that. I hope it is clearly visible to all.
Yes, ma'am.
Yes. Now you can see the study hours of male and female students are given here to us. I don't know for what purpose I have made this column. You can delete this. So you can see we are having the two groups, male group and female groups, and these are the study hours given for both the groups. We want to compare the mean study hours for male and female are same or not, right? So can anyone tell me what can be the null hypothesis in that case?
There is no significant difference in the salaries of study hours of female and male.
Yes, thank you, ma'am. Good.
Alternate will be there is significant difference in study hours of female and male.
Yeah, only you, if you can use the word mean, so it is good. Otherwise, I think that way also we are writing. There is no significant mean difference in the study hours of male and female students. That way you can make your null hypothesis, right?
Yes, ma'am.
So this is our null hypothesis. We want to test this null hypothesis at suppose 5% level of significance, right? So now what you need to do, you need to go to the data tab. You can click on that and then you can find the data analysis, which we have already added yesterday. So I hope I do not need to repeat the process of data analysis toolpack. I hope it is clearly visible to all.
Ma'am, please repeat. Actually, yesterday I joined late.
Oh, so I think, ma'am, recordings are provided by the organizers.
Okay,
So
ma'am.
I think you
See
can
that.
check that. But again, I'm repeating. This is the one more time I'm repeating. You can go to the file menu. You can click on the options. Then you can find the add-ins. Then you can go to the manage, and here you can select Excel add-ins. Then you can press go. Then you can select analysis toolpack and you can press OK. Once you will do this process, you would be able to see this data analysis toolpack available under that tab data. Fine?
Yes, ma'am. Thank you.
Yes. Okay, welcome, ma'am. Now you can click on this data analysis toolpack and you can scroll down and you can explore. Here we are having the t-test available with us. It is showing us 2 sample assuming equal variances. It is also showing us 2 sample assuming unequal variances. So firstly, you need to see, because as I said, I think yesterday also I have said this thing. Generally, in case of this parametric test or non-parametric test, we are having certain assumptions. So there is a one assumptions in case of t-test. We need to check the homogeneity of the variance, means whether in the two groups the variance is similar or not, that you need to check. So in that case, we need to decide upon whether the variance is same or not. Accordingly, we will select the one of the options, whether we are going with the equal variances or whether we are going with the unequal variances. Is it clear to all? Please, any confirmation, any doubt?
Yes.
Okay. Okay. So now to check firstly that particular thing, you can go to the F-test 2 sample for variances. I hope visible to all. You can scroll up this and you can find this. It is alphabetically written all the tools. So you can see alphabetically F-test, right? Can I click on OK?
Yes, ma'am.
Okay. So once you will click on OK, you would be able to see it is showing us the dialog box of the F-test 2 sample for variances. It is asking us the range of our variables. So it is asking us in the 2 sections, we need to provide the ranges. So suppose I'm providing the range for the first variable here. So I'm selecting here my first variable, that is female, or the study hours for female. I have selected the first range, and then I'm coming to the second box and selecting the study hours range for males. Done. And then you can see I have selected the data including the labels of the column. So that is why I'm checking this box labels. So the yesterday one of you have made a mistake. So please be cautious if you are selecting the data using your or including your labels. Only then you need to click on this. Otherwise, your results will be different. Is it clear to all? May I proceed?
Yes,
Yes.
Yes, ma'am.
Now you can check alpha is 0.05, that is 5% level of significance. This is a highlighted field. If you want to make any changes, say for example, you are very confident and if you want to set your alpha is 1%, so in that case you can come and you can write is 0.01 also. If you want to check at 10%, you can write here 0.10. So up to you. Here I am okay with the 5%. I am not making any changes in this. Coming to the output generation option, so I'm going with the first option, that is output range, and here I am suppose selecting this cell where I want to generate my output, and then I can press OK. So I hope everyone is with me. May I press OK? Any doubt so
Yes.
far? Okay.
Yes, ma'am.
Okay, good. If everyone has performed the same thing, I will request all of you, please click on OK and generate your output. And then you will get the output in the cell which we have given there. You can find here, we are getting here the mean study hours for male and female both. The variances in the study hours for female and the male is given here. We are having 6 observations for female and 5 observations for male. And the degrees of freedom for both the groups is 5 and 4. Coming to the next, it is giving us the F value. This is the F calculated value. This is the F critical value. So here, any one of you can tell me if this is the table value, if this is the calculated value and this is the critical value. On the basis of this, what we can conclude? Anyone?
Reject null hypothesis.
Accepting the null hypothesis.
Okay.
Reject the null hypothesis.
Okay. Anyone else? Anyone? F calculated is greater than F critical or F tabulated. Now, can anyone tell me?
There is a significant difference in study hours of male and female.
Okay, I think firstly I need to make you clear this thing. If we are talking about the variances using the F test, so in that case, the hypothesis would be the variance is equal. Okay, variance is equal between the groups. This would be your null hypothesis in case of F test, and alternatively you will write variance is not equal between the groups. Is it clear?
Variances are not equal.
It is not equal. Very good. Now you can see because whenever the calculated value is greater than the critical value, in that case we are not going with the null hypothesis, and that way we can say the variance is unequal. Right? Is it clear?
Yes, ma'am.
Yes. So this way we have understood this thing that variance is not equal between the two groups. So now again when I'll go to the data analysis, now I am very clear that I need to go for the second category, that is two sample assuming unequal variances. Is it clear to all? Any doubt so far? May I click on this?
Yes, ma'am.
I don't know why our voices are very less today. I think, am I clear or not? Are you getting me or not?
Yes, ma'am. It's very clear.
Yes, ma'am.
Okay. Okay, thank you so much, because it is little, I'm feeling like boring. Nobody is talking to me. So please talk to me or give me response when I ask something, because it is little difficult in teaching in online mode. So
Ma'am,
coming,
primarily
yes,
because we are doing along with you.
yeah, I
So
understand
that
your
would be
point,
the
ma'am.
reason. Like, so
Understand,
our
understand.
concentration is something that is very
Okay, no issues.
yeah, otherwise it's very good, wonderful.
Okay, thank you. So coming to the two samples assuming unequal variances part, you can find here we need to provide the range of the first variable and the range of the second variable, same as we have done for the F test. So I'm again selecting the first variable range, coming to the next section and providing the second variable range, coming to the hypothesized mean difference. So here you do not need to write anything. You can come to the labels and check this box labels, because I have selected my data including the labels. You need to decide whether you have included the labels or not. If you have not included, do not click on this box. Got it? Coming to the next section, it is asking us to provide the alpha value. By default, it is 5%. I'm okay with it. If any one of you want to make changes, that you can make using your keyboard, right? Coming to the output generation section, here I am generating my output on the same worksheet and giving the blank cell where I can generate my output. So giving that and pressing OK. So may I press OK? I think process is same, which we have done for the F test. May I?
Yes, ma'am.
Okay. Thank you. So pressing OK, you would be able to see we are getting the results here. Now, mean variance, these all are the same which we have already found in the previous section of hello. Am I audible?
Yes,
Yes, ma'am.
Yes, sorry.
You're audible.
The power cut at my end, so Wi-Fi has suddenly stopped working. I'm closing my video because I'm working with my mobile now. So maybe it will not miss frequency band problem would be there. So I have closed my video now. Yes, coming again to the same thing. My screen is visible to everyone or not?
Yes, ma'am, I had a question.
I think I was on Excel, right? Yes. Visible?
Yes, ma'am.
Yes, ma'am.
Ma'am, I had a question. Could you help? Actually, I'm not understanding that that if you see the sample, right, is in the male, the last one is empty. So is that being counted as zero? How are we doing it? Like there's no data sample there, right?
Ma'am, that is the case of independent sample t-test. In that case, whatever two categories you are having, it is not mandatory that in both categories the sample should be same or the number of observations should be same. It is not the case. So in that case, you can see it is giving us for the female we we are having 6 observations, and for male we are having only 5 observations. So there is no problem in case of independent samples t-test.
Okay, thank you so much.
Yeah, most welcome, ma'am. So coming to the section again, I talk about yes. So here you can see mean variance observation. This is already we have seen. Hypothesized mean, we have not passed anything, so it is taking by default as 0. Coming to the degrees of freedom, it is coming as the 7. Then T stat. T stat means this is your calculated figure. This is my calculated value of T. Then this is the critical value for one tail test, and this is the critical value for the two tail test. Now you can see one thing I forgot to tell you here. You can find here when I was talking, I hope you can see I am on the F test table now. Firstly, I want to tell you one thing I forgot to tell you here. Here you can see when we are applying the F test using the Excel, in that case Excel is only giving you the p value for the one tail test, and it is not giving you the value for the two tail test. Is it clear to all?
Ma'am, just now you rewrote the two tail, right?
Where, ma'am?
The previous one for the F1, We mentioned it as two tail in the beginning, na?
Where, ma'am?
It can be
Ma'am,
one tail or it can be two tail. Anything it can be, right? Or it should be for F test, it should be one tail.
firstly, you need to understand the thing what I'm saying to you. When you are calculating F value, at value calculated will remain same whether we are applying for one tail or two tail. It will not change. Got it?
Yeah, value will
But
not
I'm
change. Yes.
Yeah, but I'm talking about these figures. So that is, I'm again repeating for you. I forgot to tell you this thing. Here we are getting F critical for one tail and also we are getting P value for one tail. If you are considering, because generally we are applying F test for the two tail, we are applying F test as a two tail test, right? So in that case, what you need to do, you need to double these figures. Got it? Is it clear, ma'am?
Double into
Yes.
two, you have to.
Multiply by 2.
Right.
Right, and similarly the one in the p value also you need to multiply by 2 for the two tail test. Is it clear?
Yes, yes.
Yes, so that way you need to make your decision. So again, when I'm coming to the t statistic, you can see if we are using this t test for the two tail test. So this is the calculated value and it will remain same whether we are applying one tail test or two tail test. Calculated value will not change. Is it clear to all?
Yes.
Yeah.
Yes.
Now, if suppose I have made my hypothesis for the two tail test, so I need to consider these two things, right? So suppose I am writing here that T calculated, right? Which is, it is quite clear, it is 1.47. Then if I am applying two tail test, so my T critical is 2.36, right? Now I can write that T cal is less than T critical, right? Is it clear to all? Is it clear to all? Any doubt? Am I audible?
Yes, ma'am, you are audible.
Yes,
Okay.
ma'am.
Okay, so you can find that we have compared these two figures and calculated value is less than critical value. So that means we are not going to reject the null hypothesis. Na? We are writing do not reject the null hypothesis. Okay. So if we are not rejecting the null hypothesis, that means we are concluding this thing that there is no significant mean difference in the study hours of male and female. Okay, fine. Fine, everyone. Now, if I want to compare or make my decision on the basis of p value, so you can write that p is greater than 0.05 because it is 0.018. So it is greater than 0.05. So we can again say this thing that we do not reject the null hypothesis. So either we are using this particular parameter as the decision rule or this particular thing as a decision rule. Both are stating the same thing that we are not going to reject the null hypothesis and we are concluding that there is no significant mean difference in the study hours of male and female students. Is it fine to everyone?
Yes.
Okay. So further, you can find again you are having two sheets for one or two sheets. I think two sheets are there for your practice purpose. One I think I have added to explain you the things. So that I'm keeping here because it is making confusing. Yeah. Now coming to the paired sample status. So for the purpose, I am moving to the slides again. I hope my slides are visible.
Yes, ma'am.
Yes. Thank you for the confirmation. Now coming to the paired sample status, you can find here, if I want to make the hypothesis for paired sample t-test, as I have cleared the concept of paired sample t-test, so directly now I'm talking on the hypothesis part. So here you can make your hypothesis as there is no significant mean difference in DV during the two intervals. Or alternatively, you are saying there is a significant mean difference in the DV during the two intervals. For example, we want to compare the weight of the particular group of people with those who are opting for any diet plan. So suppose we are writing there is no significant mean difference I think mean I have written twice. You need to skip one of the mean. So suppose I am writing there is no significant mean difference in the weight before and after the diet plan. Alternatively, you can write there is a significant mean difference in the weight before and after the diet plan. That way, you can write your hypothesis in case of paired samples t-test. I think these are the steps which I have already told you. So I am directly coming to the Excel now for the paired samples t-test. So I hope I am clear on the part of paired samples t-test. Can I proceed with the applying of paired sample t-test using Excel? May I?
Yes, ma'am.
Yes. Now you can see we are having the data. Probably suppose this is the data of maybe height in inches. So now you can see, I think not height, this is the weight. I think weight also it is not possible. What particular variable name I can give it to you, give it to it? I need to check.
Will it be height in centimeters?
Maybe height in centimeters. Yeah, sorry.
Weight in pounds.
Right, yeah, that can also be there, or height in centimeter is also a good idea that we can take it. Suppose this is given, these are the heights before taking any particular plan and after, before joining any particular.
Height cannot decrease, ma'am.
Sorry?
Ma'am, height will not be subject to any reduction.
Yes, right. So we can take weight in pounds.
Weight in pounds.
Yes. Is it fine? Fine, sir?
Yes, ma'am.
Yeah. So now we want to see whether the plan, whether the plan, diet plan, which are taken by the people before taking that plan, what is their weight in pounds, and now after taking that, what is the weight in pounds. So these are the pounds given. Now we want to check whether the plan is diet plan is effective or not. So that way, firstly, we need to write the null hypothesis. So the null hypothesis would be, can anyone tell me what would be the null hypothesis here?
No significant difference before and after.
There is no significant mean difference in the weight before and after the diet plan, right? Alternatively, you can write there is a significant difference. Other way around, you can write your null hypothesis that
Diet plan is ineffective.
yeah, right. Diet plan is ineffective. Or alternatively, you can write diet plan is effective. So this way, you can, these are the two ways of writing your hypothesis. Now again, coming to this particular section, now how you can apply the paired sample status. For that, you need to go to the data analysis. Under the data tab, you can find it, and then you can scroll down and find, sorry, you can find here only that the t-test paired two samples for means. It is given here. I am pressing OK here. Once I'll press OK, I can see the dialog box coming here. And here you can see we need to firstly give the ranges. So suppose I'm selecting the range of my first variable. Then I'm selecting the range of my second variable. Coming to the hypothesized mean difference, if you want, you can write 0 also. If not, even Excel itself will make it 0. Then coming to the labels, you can check the box if you have selected your data, including the labels. Alpha label is 0.05, that is 5%. Then here you need to select the output option where you want to generate your output. So suppose I want to generate my output here. So I have given that particular cell where I want to produce my results of the paired samples t-test. So this is what you need to set here. I hope it is clear. May I press OK?
Yes, ma'am.
Yes.
Can you repeat it again, please?
Uh, okay, from where?
Ma'am, actually, I was not getting the data analysis, ma'am. I was trouble. Like descriptive statistics, we have to select.
No, ma'am, you need to scroll down this bar. And at the bottom, you can find t-test paired true sample for means.
Two pair. Yeah, yeah. I was not able to get that. Okay. Yes, after that I can proceed. Okay.
Okay.
Fine. Okay, thank you, ma'am.
Okay. Most welcome, ma'am. And then after doing that, I am coming here and giving the blank cell where I want to generate the output. So I hope everyone is with me. May I press OK?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yeah. So I am pressing OK here. Once I'll press OK, you can see here. We are having the paired output for the paired samples t-test. You can find here that the mean weight before taking the diet plan was this, after taking the diet plan was this. This is the variance in the weight before taking diet plan, after taking diet plan. Number of observations are 8 and 8. So this is the case, means in paired sample t-test, it is a mandatory condition that your in both the cases, means before and after case or pre and post, whatever is the case, every time the sample size would remain same and the same number of people you need to use for both the cases for collecting the data. So I think one of the ma'am, I think Parul ma'am was there when she was asking in case of independent sample t-test. So in case of independent sample t-test, there is no problem. You can easily keep the different sample sizes for the two groups. But in case of paired sample t-test, it is a mandatory condition that the sample size should be same in both the groups. Is it clear?
Yes, ma'am.
Yeah. Coming to the Pearson's correlation. So again, it is important part. Again, whether you are applying the paired sample t-test using Excel or SPSS. In both the cases, you always get the correlation because we want to see for the same sample, we want to see whether there is any impact of that particular thing, whatever they are taking or whatever they are using. So for the purpose, always correlation will come there. So you can find here correlation value is coming as minus 0.17. So it's showing that there is a weak correlation between these two figures and the correlation is the negative correlation. Coming down, hypothesized mean we have defined there as 0. It is coming as 0. Degrees of freedom is 7. T statistics means this is the T calculated value. So I'm writing that the T calculated is 3.71 and the T critical is 2.36. So now when I compare this, what conclusion we can draw? T calculated is greater than T critical, right? And this is the case. In that case, what we will do?
Reject.
Hypothesis. Diet plan is effective.
Yes, do not accept H0. And we will go with the alternative hypothesis and we can say this thing that the diet plan is effective. Fine?
Yes, ma'am.
Yes. So this is the this particular thing. Now, any one of you can tell me using the p-value how we can yes, anyone?
Ma'am, actually, you were not audible for few fraction of seconds. Can you please repeat?
Okay. I'll repeat again. As I explained you using the table value and the calculated value, the interpretation part. Now, can I expect from any one of you that how we can interpret using the p-value? This p-value is stating us what? Can anyone tell me that?
P is less than 0.05, so we can accept the alternative hypothesis.
Very good. Very good. Thank you so much, ma'am. So I hope it is clear to everyone. Right?
Yes, ma'am.
Yes, ma'am.
So I think this is all from my side for the day. We have
Ma'am, can I ask?
yes.
Ma'am, like this, in this we are having a single group where a particular diet plan is being implemented, and before the diet plan and after the diet plan, what changes were there in the weight, we have seen that. This is for a single group. If suppose we are having two groups, And we are giving different type of diet plan in both the groups. Like for example, the same thing, we are having a obese patients. Like suppose in one group we are having 20 obese patients, and in another group we are having 20 obese patients. In first group we are giving some kind of diet chart to the patients, and we are measuring the weight prior to the treatment, I mean the diet plan, and after the diet plan, for about like for after about 1 month suppose. And in the second group of patients where we are having the same type of patient, like the obese patients with the same type of BMI and everything, like the characteristic is same. So in that case also, some another type of diet plan is there, and we are measuring the weight prior and after the diet plan, that is at an interval of 1 month. So in this case also pair to like the pair T test will be done, or how will the interpretation will be done?
I think Vandana ma'am, you have asked the same question of the medicine
Yeah, well,
also.
right.
So again, the case is same. I don't think so. I need to repeat it again, right?
Okay, so yes, ma'am, that is what I'm asking. So paired sample T test will be applicable in these type of studies, right?
Yeah, that is I said to you. But I think again I'm telling you, purpose is very important, ma'am. What type of things you want, whether you want to compare two diet plans or whether you are comparing only one diet plan on the two groups, that you need to decide upon. As I have explained you through the Excel sheet, so accordingly that you need to see how you are arranging your data and what is the purpose behind your research study, that you need to decide upon. Always whenever we are talking about the data analysis, it is not like this is the variable we are having, this we can perform, this we can do. It is not like that. You need to see your objectives also. Fine.
Yes.
Yes.
Ma'am, one more thing, ma'am. Here this P1 tail and P2 tail, both are below 0.5.
Okay.
Is it like possible that in one tail it will be more or less, or both the cases it will be same? Like it will be less than like value that level of significance, or some way or the other there will be difference?
Not getting.
Or like both all the times when it comes to one tail and two tail, there will be less or more compared to level of significance, or there may be difference?
Obviously there can be a difference also. As you can see, when I was talking about the F test, so that is
Yeah,
why
there
I
it
have
was
focused.
reject.
Yes, that is why I have focused your attention on that point. If you are considering for the two-tail test, your decision will be reversed in that case.
Okay.
Yeah, so it can be a case, ma'am, depending upon you are using one tail or two tail. So that is why it is also an important thing. You need to see this thing, whether we are going for one tail or two tail test. Accordingly, p value will also change, and then accordingly you will compare with the level of significance to make your
So
decisions.
which is comfortable when, like what type of tail we have to prefer usually?
As nothing is right so far, ma'am. This I think I haven't studied anything on this, but generally people are using two-tail test most of the time. Whatever researches or research papers I have studied, I have seen this thing. Mostly people are going with the two-tail test. They are not saying less than or greater than case. They are directly saying they are not equal.
Okay, ma'am. Thank you.
Yeah.
Ma'am, can I ask a doubt?
Yes,
Like in the case
definitely, ma'am.
of, we get, when it is a calculated values that you are getting, we get the p value as well as we get the calculated and the critical values, right? Will there be a chance that the p values and the critical values contradict each other? That
No.
is, you get a p value less than
No.
0.05.
No, it will never. I think I haven't seen such a case so far. My this teaching experience, I haven't seen any experience or any type of phenomena like this. What you are talking about? Usually, they will not contradict them, because generally, whatever is the statistics or the science behind the p value, it is always coming from that figures only. So it will
Yeah,
never
that is
contradict.
why,
It will never
because
contradict.
I don't get me wrong, because I just attempted that practice one of paired t test. I hope you have the answers with you. I get a p-value of 0.002, which is less than 0.05. So obviously, we start out with a null hypothesis that there is no difference in the effect. There is no effect in the training that
No,
is given.
alternatively, you will go with the alternative. Because if it is less than 0.05, so that means you will go with the
You go for
alternative
the
hypothesis.
But what I'm getting is the calculated the t value. The t value is a negative 3.59, and a critical value is 1.8, which is positive. One tailed is also positive.
One minute, ma'am. 1 minute here. I mean, I need to ask you. You have applied this test using which particular software?
Excel itself.
Okay. So
No, I
generally,
was
ma'am.
just trying out the practice problem.
Okay, no issues. I understand your point, but the thing is, in that case, you need to understand this thing. T value can never be negative value. This is the case. Generally, if you have seen the books of
Yes,
research
that,
methodology,
I understand. I
or
understand.
is right.
Please
So it is in the mod. You can see there is a mod figure. So it can never be a negative figure.
So even if that it is Excel is giving me back as a negative value, we should consider it
as a positive figure.
Yes, I missed that point. Okay,
yes.
Thank you so much.
Welcome, ma'am. Okay, so any doubts so far? Any other thing?
No, ma'am.
Okay, so thank you everyone. This is all from my side for the day. We'll resume the session tomorrow with some other topic. Okay?
Thank you so much, ma'am. It was really a wonderful session.
Thank you, ma'am. Thank you, sir.
Thank you so much.
Thank you everyone. So I have one request from all of you, those who are liking the session, and if they can make a small video for me as a feedback, and if they want to share with me, they can share with me. I drop my mail on the chat box.
Ma'am, whatever you are like taking, it will be on the YouTube. Now, if you want to check anything,
I think it is available there. Anyone? I think Yogra sir, are you there? Anyone from RFI? Yogra sir, I think the sessions is available there in RFI, no? Oh, sorry, on YouTube. Yes. Ma'am, you can go and see there if you want to see, if you have missed something.
Okay. Okay. Thank you.
Thank you, everyone. Good night.